To solve this absolute value inequality, you have to write it as it appears without the absolute value brackets. And then you must write it a second time with the x minus 5, but flip the inequality sign and change the sign of the number on the right. Then you go through and solve both of them. X greater than 6 plus 5 is x greater than 11. And on the right, x less than negative 6 plus 5 is x less than negative 1. Set up the number line. You need a negative 1. So we'll put a 0 here. There's negative 1. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. All right. So now we need an open dot here and here. According to this, x is greater than 11. And according to this, x is less than negative 1. You cannot blindly shade these in just yet. With absolute value inequalities, chances are good you could run into something in which everything is shaded or nothing at all, or just one part. Pick something from the middle area, which is not covered by the lines. I like 0. 0 minus 5 is negative 5. Absolute value is 5. 5 is not greater than 6, so this does not get shaded in. Pick something out here on the right, like 12. 12 minus 5 is 7. Absolute value is 7. 7 is greater than 6. Shaded in. Pick something back here on the left, like a negative 2. Negative 2 minus 5 is negative 7. Absolute value is 7. 7 is greater than 6. So this would be your solution here. To solve this, you must write it as it appears without the brackets, and then again, as it appears except you flip the inequality sign and change the sign of the number that's on the right. On the left, you'll have x less than 12 minus 5, which is x less than 7. On the right, you have x greater than negative 12 minus 5, which is negative 17. So go to the number line. You need a positive 7, so we'll put 0 here and go 1, 2, 3, 4, 5, 6, 7. That's an open dot. And then we have x greater than negative 17. We have to go back, and I'm going to skip on this. It's going to be 3, 6, 9, 12, 15, and then 17. Negative 17 with an open dot. X is less than 7, and x is greater than negative 17. So we'll check each area. We'll choose the 0 in the middle. If I put a 0 in this inequality, I'm going to come back with 5 less than 12. That is not true. Or, oh, I'm sorry, that is true. That's awful. Yes, that is a true statement. 5 is less than 12. And then over here on the right, 8. If I put an 8 in from here, I'll get a 13. 13 is not less than 12. So we do have to shade in the middle, but not over here. And on this end here, a negative 18. If I put a negative 18 in, I'll get back 13, less than 12. That's not the case. So you don't shade that in either. This is your solution. To solve this, we have to write it as it appears without the brackets, and then write it as x minus 6 less than negative 4. Solve the left one to get x greater than 4 plus 6, which is going to be x greater than 10. And on the right, x less than negative 4 plus 6 is going to be x less than 2. On the number line, we need a 2 and a 10. So here's 0, 2, 3, 4, 5, 6, 7, 8, 9, 10. Open dot, x less than 2, x greater than 10. If I plug in a 0 from the left side, I'll get back 6 greater than 4, so that works. In the middle, if I plug in a 4, I'll come up with a 2 greater than 4. That doesn't work. Over here, an 11 would give me a 5. 5 is greater than 4. So this is your solution. This is a special case, and it is absolute value of x plus 4, close the value, and it's greater than negative 3. The reason why this is a special case is because the answer is given to you in the problem. There is no work to do if you think properly and understand what's being told to you by the problem. Absolute value brackets. If that's all you have on the left-hand side is a set of absolute value brackets and an expression or whatever in it, the sign of the answer that comes out of that must be what sign? Positive. How many positive numbers are greater than negative 3? All of them. So your answers should be all real numbers. And you're finished. This is the second special case, and it's the absolute value of negative x minus 6. Close that value and less than negative 2. The answer is right in front of you. Absolute value, and that must be all that you have on the left, because outside of the brackets you could have a plus 2, a minus 3, or whatever. It's in the case where you just have the brackets, an expression inside. It comes out positive no matter what. How many positive numbers are less than negative 2? None. So your solution would be no real solution. Or you could write no real numbers. To solve this absolute value inequality, you're going to have to write it as it appears without the brackets, and then write it as it appears by flipping the inequality sign and then changing the sign of the 12. That's the only difference, which would be here and there. Solve both of them to come up with 2x greater than 12 less than 8, which is 2x greater than 4. X would be greater than 2. And then on the right side we have 2x less than negative 12 minus 8, which would be a negative 20 on the right. X less than negative 10. Now we need the number line here and here. We have a negative 10 and a positive 2, so we'll go 0, 1, 2, and that'll be an open dot. Go back 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 to negative 10 and make an open dot. X is greater than 2, so we go this way, and x is less than negative 10. We go that way. So go back to the original inequality up here and choose this 0 from the middle. If I put 0 in up here and evaluate, I come back with an 8 greater than 12. Is that true or false? That's false. What if I put a 3 in from this side and get 6 plus 8 is 14, which stays 14? Is that true? Yeah. And what about this side over here? If I put in a negative 11 and come back with negative 22 plus 8, which is a negative 14, absolute value is 14. Is it greater than 12? Yes. So there is your solution.